Hey, how's it guys? Welcome back to my channel. This is the Bedford River in England. In the 19th century, two men would come here to conduct experiments questioning the shape of the earth. On to the next conspiracy earther benefit of the doubt. I am going to tell you about a few people, starting with Samuel Burley Rowbotham. Samuel Rowbotham, writing under the name Parallax, became the principal figure in the 19th century revival of the modern flat earth movement. Samuel's question was pretty straightforward. If Earth is a globe, should the curvature of its surface be measurable across a long, straight stretch of still water? Rowbotham believed the answer should be yes. So, what was his hypothesis? He used the accepted spherical Earth circumference of roughly 40,000 kilometers and calculated the expected curvature. His calculation was that the expected drop from Earth's curvature increased with the square of the distance. For each mile of distance, he allowed for 20.3 centimeters of curvature multiplied by the distance again. So, at 3 miles, he calculated 6 feet of curvature, and at 6 miles, 24 feet of curvature. His reasoning was simple. If the predicted curvature could not be observed, then the spherical model was in trouble. So, what did Samuel actually do? His first Bedford experiment was in the English summer of 1838. A boat was sent along approximately 6 miles of water between Welch's Dam and Walney Bridge. Rowbotham placed himself in the water with a telescope, his eye only about 8 inches above the surface. The boat carried a flag above the water. He reported that he could see the boat and flag for the entire 6-mile distance. According to his calculation, the top of the flag should have been about 11 feet below his line of sight at the far end if the Earth were spherical. That was his first major result. But he didn't stop there. He then conducted a second experiment using 6 flags, spaced 1 mile apart, with their tops at the same height above the water. Looking through a telescope along a line of flags, he reported that they remained aligned. He interpreted that as showing that the water surface itself was horizontal rather than curved. He also described experiments using a theodolite, including observations from the middle of the 6-mile stretch and a surveying method known as forward leveling. And he continued repeating or revisiting these observations in 1844, 1849, 1856, and 1862. What were his results? Rowbotham consistently reported that he was not detecting the curvature he expected. And from his perspective, that was significant. But there was another physical variable in the experiment: the atmosphere. Light does not necessarily travel in a perfectly straight path through an atmosphere whose temperature and density vary with height. And that is atmospheric refraction. And Rowbotham's original sightline, only inches above the water, was particularly vulnerable to it. In fact, Rowbotham himself discussed refraction in his later writings, but he treated it as insufficient to explain the observations. So, what was his deduction? Rowbotham took his observations as evidence that the water surface was not curved. And from that, he concluded that the Earth itself was not spherical. He then expanded that conclusion into an entire alternative cosmology, eventually publishing Zetetic Astronomy, Earth Not a Globe. The first pamphlet appeared in 1849, and the work was subsequently expanded into book form. So the chain was observation, interpretation, deduction, cosmological system. And now someone else was going to test the same basic question. The next person I want to tell you about is Alfred Russel Wallace. He was actually answering a challenge. In 1870, he accepted a challenge from John Hampton to demonstrate the curvature of the Earth. They were asking essentially the same question. Can the curvature of the Earth's surface be measured across the Bedford level? But Wallace challenged the experimental design. His hypothesis was, if the Earth is curved, then 3 markers positioned at the same height above the water should not appear to lie along one straight line over 6 miles. The middle marker should appear higher. The expected effect at the middle point was roughly 5 to 6 feet. In March of 1870, Wallace used a 6-mile stretch. He placed a large target at one end, and 3 miles away, he placed a central staff carrying 2 discs. At the opposite end was the telescope. The relevant reference points were all positioned at approximately 13 feet 4 inches above the water. That was a major difference from Rowbotham's original arrangement. Instead of trying to sight almost directly along the water, Wallace raised the observation height substantially. He also introduced a central reference point. That meant he wasn't simply asking, can I still see the distant object? He was asking, where does the middle point appear relative to the 2 end points? That is a much more controlled geometric test. Wallace also explicitly recognized that atmospheric refraction could affect the result and estimated its effect. So, what were his results? The central marker appeared above the line between the 2 end markers. The observations were made using both a large telescope and a precision level. But there was disagreement about what the result demonstrated. Wallace's referee, a guy named Coulter, concluded that the experiment demonstrated convexity. William Carpenter, acting for Hampton, disagreed. Because the referees could not agree, the matter went to the agreed umpire, John Henry Walsh, editor of The Field. Walsh ruled that Wallace had demonstrated the curvature of the canal to his satisfaction. So, Wallace concluded that the experiment demonstrated convexity consistent with Earth's curvature. And notice the change. Wallace hadn't simply repeated Rowbotham's experiment and obtained a different visual impression. He changed the geometry of the test. He raised the sightline, He introduced a central measurement point, he considered refraction, and he measured the relative positions of 3 points rather than relying on the continued visibility of one distant object. That is experimental science. When an observation is disputed, change the experiment so the competing explanations can be tested against one another. There were subsequent observations. Rowbotham did not accept Wallace's results. In April 1870, he returned to the area himself and conducted another observation, which he presented as a further demonstration against curvature. So, the argument did not end in 1870. The observations continued, the interpretations continued, and the disputes continued. So, who else was involved at that time? There were several people. John Hampden was the flat earth advocate who issued the 1870 challenge that Wallace accepted. William Carpenter disputed Wallace's interpretation of the result. Coulter, the other referee, supported Wallace's conclusions. And there were earlier and later challenges surrounding Rowbotham's claims. But within this particular period, those are the people directly relevant to the Bedford level dispute. And now I want to stop talking about the experiment because there is something about the place itself that I didn't appreciate until I went looking into the history. The thing that stopped me dead is that the Bedford level was not a natural formation. The old Bedford River was engineered. It was part of the enormous drainage works constructed to control the waters of the fens. Human beings designed and cut these waterways. They created the long, remarkably straight channel that became the setting for one of the most famous 19th century arguments about the shape of the earth. Because when we hear Bedford level experiment, it is very easy to imagine some pristine natural feature that simply happened to provide humanity with a perfect 6-mile window into the geometry of the planet. People built it. And then somebody came along and said, look at this exceptionally straight stretch of water. If the earth is curved, it should be able to detect that curvature here. And that observation became enormously important in the history of the modern flat earth belief. Now, that doesn't make the observations worthless, it doesn't make Rowbotham stupid, and it doesn't make the experiment automatically invalid simply because people constructed the channel. But it does make the history rather more fascinating because we are no longer dealing with nature versus theory. We are dealing with an engineered environment, an optical system, surveying methods, atmospheric conditions, geometric assumptions, and human interpretation, all interacting in one experiment. And that is precisely why I keep coming back to the same principle. Seeing something is not the end of the investigation. In fact, it should be the beginning, because the question isn't merely, what did I see? It is, what physical processes could have produced what I saw? And once you ask that question, you have moved from an observation to an investigation. Thank you so much for watching. I hope you enjoyed this installment of Flat Earth Everywhere, just never all at once, giving conspiracy earthers the benefit of the doubt. So, guys, please stay safe, and I will catch you in the next video. Bye.